So for question 11, we're told that a point P lies on a line. We don't have any numbers. And it also lies on the curve, we're told a little later. And we're in that relationship between the line and the curve, it says that there's a tangent at P, which means the line and the curve only has one point of intersection. And we're told to find the coordinates of P, giving the y coordinate in terms of m. Okay, so it's confusing because there aren't numbers, but we'll just do what we would normally do. If we're trying to find a point of intersection, we're solving the equations, simultaneous equations. And so y equals the line, y equals the curve, and so we say, well, they equal each other. mx plus c is equal to negative m divided by x. We rearrange that, take the negative m on x over to the other side, and if we multiply by x, we can see that it's a quadratic with mx squared plus cx plus m equals 0. Now we need to give our answer in terms of m. We don't want the c there. And so we know that because there is one point of intersection, if we're trying to solve this quadratic to find x values, there's only one answer, there's only one solution. And the only way you can have one solution for a quadratic is if the discriminant is 0. And so b squared minus 4ac is 0. So we take what we have and say, all right, well, what's b squared minus 4ac? We get c squared minus 4 times m, which is c squared is equal to 4m squared. All right, taking the square root of both sides, we get c equals 2m. Now we know that they're both positive. We don't have to deal with the negative square root because it tells us in the question that m and c are both positive constants. So we can say that c equals the 2m. Now we can replace the c in the quadratic with the 2m and go, all right, so this is the solution for the point of intersection. And if we look at that, we would go, oh, look, m factorizes out of that quadratic, leaving us with, in brackets, x squared plus 2x plus 1 equals 0. Now, if you multiply anything to get 0, it just means the brackets is 0, and we can factorize the brackets by inspection into x plus 1 squared equals 0, which gives us the point of intersection where x is equal to negative 1. All right, that's great. So that's the x point of the intersection, the point P. We want to find the y, and we can do that by putting it into either equation. We can put it into the straight line, or we can put it into the curve. It doesn't really matter. I'm going to choose a straight line in this case where it was mx plus c, but c of course we know is 2m. Actually the curve is probably easier. And so we get x is negative 1. So let's take the 2m and subtract the m, and we just get 1m. And so our point P is negative 1 and m. So the question can be asked, is there another way that we can solve this? And there often are multiple ways you can solve a question. And we might be thinking, well, if I know the gradient of the line, can't I do the differentiation of the curve and say that equals the gradient? And you certainly can. And so the gradient is m, because that's all we know. And the function is negative m times x to the minus 1. When we do the differentiation, we get mx to the minus 2 because the negative 1 came down and made the negative a positive. And so when the gradient is m, we have m is equal to m over x squared. X squared comes up, m goes down, m divided by m is 1, so x squared is 1 and x is plus or minus 1. All right, so we have two values, one where x equals 1, and we can find out y by putting x back into the equation. Let's put it back into negative m divided by x. So when we put 1 in, we just get y is negative m. And when x is negative 1 and we put negative 1 in, we get negative m divided by negative 1. So y is just m. Now, it seems like we've got two answers here, but p, we need to find coordinates, and it seems like p is just 1 point. So what's the other bits of information they told us? M and c are positive. Okay, so in both answers we could say that m is positive, and just one has a negative in front of it. It doesn't mean that m is negative. M is still positive. It's just that y ends up being negative. So what we want to do is we maybe want to check to see that c is going to be positive in each case. And so to do that, we'll use the line y equals mx plus c, and we'll put in the point where x is 1 and y is negative m. And we'll get negative m is equal to m plus c. So c is equal to, when you take m over and subtract it from negative m, you get negative 2m. Now, that's a big problem because m is positive, and then when you multiply it by negative 2, you're going to get a negative, which means c is negative. So this is not a possibility, or it's not a possible answer. So let's check the other one. This time we put in m where y is, and we're going to put negative 1 where x is, and we'll get m is negative m plus c. We take the m over and we add it, and we get c is equal to 2 times m, which is perfect because when m is positive, c is also positive. So that tells us, yes, that's the answer that we're looking for, and all we have to do now is write the answer. For part B, they tell us there's a normal at the point P which intersects the curve again at another point Q, and we have to find the coordinates of Q. Well, in part A they told us the line is the tangent, and so the gradient of that line is the gradient at point P. The normal is the perpendicular gradient, and so that's going to be negative 1 on m. And we found the point P before in part A, which is negative 1 and m. Now that we have the gradient and a point, we can find the equation of the line. And so we put the values in, we'll get m is equal to the gradient negative 1 on m times x value negative 1 plus c. Rearranging, we find that c is going to equal m squared minus 1 divided by m. So the equation of the normal, it looks complicated, is y is negative 1 on m times x plus c, which is m squared minus 1 over m. Now we're trying to find where this intersects the curve, which is negative m on x. And how do we find where things intersect? Well, we solve simultaneous equations. And so we're going to say one equation equals the other because y is the first, y is the second. So they equal each other and try to solve. Now when we look at that, we go, oh, it looks like a quadratic. Let's bring the negative m over x onto the other side and then multiply everything by x, and we end up with a quadratic. Negative 1 on mx squared plus m squared minus 1 on mx plus m equals 0. Now, how do we solve that, right? You could try and do the quadratic formula. It's going to be horrible. But we can use our smarts and go, we already know one of the answers because it goes through to point P, and we know the x value of P is negative 1. And if that's true, then x plus 1 is a factor. Now, if we know one of the solutions to this equation, we can just say, I'm going to make two brackets and I'm going to deduce the other bracket from what I already know. And so if we write x plus 1 and we go, well, how do I create the constant in the expansion? Well, it's the constant in the first bracket times the constant in the second one, which means we must have a m as the constant in the second brackets, because 1 times m is m. Now we can do the same thing for the x squared term, because the only way you get the x squared term is the x term in the first brackets times the x term in the second brackets. And so in the second brackets, the x term would have to be negative 1 on m times x, and when you multiply them together you'll get the negative 1 on mx squared. Alright, so that leaves just the single x term, and well, we should check to see if this is going to work out. And how do we check? Well, we take the x in the first brackets, multiply it by the m in the second brackets, and then we're going to add the 1 in the first brackets times the negative 1 on m by x in the second brackets. We factorize the x out and simplify, and yes, it does equal the middle term. And so we have factorized it correctly by using our knowledge of what one of the solutions is. Okay, so the other point has to be the brackets that we just found, which is going to mean negative 1 on mx is equal to negative m. Rearranging, we take the negative m over and we'll get x is equal to m squared. All right, so that's the x value of the second point of intersection. To find the y value, we put it into one of the equations again. You get to choose whether you put it into the line or into the curve. But in this case, the curve is just negative m on x. And so that looks probably easier to put it into. So we'll get y is negative m over m squared. Cancel m out and we'll have y equals negative 1 on m. So the other point of intersection, which is q, is m squared and negative 1 on m.